So last time we had completed with henna boats and streams and escalators part of time speed distance. Now today we are going to go ahead with the last part of time speed distance, which includes circular races and clocks as a concept. Okay. Now before moving ahead with the questions, I would like to first go ahead with some conceptual building on circular races, the kind of questions expected in this area, and then we'll go ahead with the questions. Okay? All right.
Okay.
So when I talk about circular races, particularly, of course, the race is on a circular track, right? Now, generally in circular races, there are three basic types of questions asked. First is, when will they meet for the first time after they start the race? Okay. Second is, when will they meet at the starting point after they start the race? And number of distinct meeting points. So we are going to look at these three variations of questions. This should ideally cover your entire circular races. Okay. So for this, let us take a simple example. Okay. So let's say this is a circular race and the track is of, let's say, 1200 meters. Okay. Now there is a person A whose speed is, let's say, 30 meters per second, and A is running in a clockwise direction. And there's a person B whose speed is, let's say, 40 meters per second, or 50 meters per second for that matter. And B is running in an anti-clockwise direction. Okay. So let's go with the first type. When will they meet for the first time? Now, for meeting for the first time, clearly the movement of the A will be in clockwise, movement of the B will be in anti-clockwise. So they have to meet somewhere in between, right? Now, how do I do meeting for the first time? It would be, your first would be your length of the race upon your relative speed will give you the time taken to meet for the first time. So what is the length of the race over here?
1200 meters.
1200. And what is their relative speed?
20 meter per second.
Are they running in the same direction or opposite direction?
Opposite. So 80 meters per
It
second.
will be 80. Understood? So when will they meet? They will meet after 15 seconds. Do we understand this? We can also verify.
Got
A at a speed of 30 meters per second will run how much distance in 15 seconds? Tell me. A whose speed is 30 meters per second in 15 seconds will cover how many meters?
450.
450. So let's say this is where A was after covering 450 meters approximately. And B at a speed of 50 meters per second will cover how much distance in 15 seconds?
750.
750. So if I calculate 450 plus 750, it has to add up to 1200. And this is where they will meet for the first time. Do we understand this?
Yes, ma'am.
Okay. What if A and B were running in the same direction? Then what would have the change been?
The relative speed.
So instead of 80, my relative speed would now be 20, which means they'll be meeting after 60 seconds. How many seconds? 60 seconds. Okay. Again, we can verify. A at this speed of 30, after 60 seconds will cover how many meters?
180.
1800.
1800, sorry.
So basically one entire round and half again. Do we understand this? And B will cover
Yes.
how many how many meters in 60 seconds?
3000.
3000. And because they are in the same direction, two entire rounds and half again. So this is where they will meet. So generally, when the direction is same, the point at which both the people will meet, by that point, the faster one will always have covered one round extra. Do we understand this? If A is covering 1.5 rounds, B is covering 2.5 rounds. So whenever both are in the same direction, the point at which they meet, that would be the point where the faster one has covered exactly one round extra. Because understand, if I'm starting from one point towards one direction, of course, the faster one is going to take the lead from the start itself. So to meet, the faster one has to cover the entire round and cross the slower one from behind. Relatively one round more.
Got it, ma'am.
Yeah. So this is how you solve for meeting at the starting point. Okay. Now, what if there are three people? So let's say A is in a clockwise direction with 30 meters per second, B is in an anti-clockwise direction with 50 meters per second, and let's say C is also in a clockwise direction with 80 meters per second. Now I want them to meet for the first time, all three of them. So what would I do is, out of these three combinations of A, B, B, C, and C, A, I will make any two combinations meet. So for example, when will A and B meet for the first time? We have already calculated, it is 15 seconds, right? If I want to
Yes.
calculate when will B and C meet, if you observe for B and C, the relative speed will be 130. And I don't think I'm going to be very comfortable with 1200 upon 130. So I might just leave this for now. And let me make C and A meet. So for C and A, if you observe, both have the same direction. So the relative speed has to be 80 minus 30, which is 50. Correct? Which means they will meet after 24 seconds. And always remember, if A and B are meeting for the first time after 15 seconds, they will meet for the second time again after 15 seconds, which means they will keep on meeting each other after every 15 seconds. Are we understanding this?
Yes, ma'am.
So if A and B are meeting after every 15 seconds and C and A are meeting after every 24 seconds, to let A, B and C meet together, we will have to just take LCM of 15 and 24. Did we understand why? And that will be nothing but 120 seconds. So all three will meet after 120 seconds. If there is any confusion, please ask.
No, ma'am.
Now, talking about meeting at the starting point. If I take the same figure and if I take the same values, if I want all three A, B, and C to meet at the starting point, when will that happen for the first time? So meeting at the starting point is nothing but LCM of time taken for each of them to reach at the starting point. So, for example, if I talk about just A will take how much time to cover one round?
40 seconds.
Correct. So, after every 40 seconds, A will be at the starting point. Agree? Irrespective of A's
Yes.
direction. यहाँ पे, because I have to reach the starting point, so whether I am running clockwise or anti-clockwise will not matter. Okay. B will reach starting point after how much time?
24 seconds.
And C will reach starting point after.
15 seconds.
So if I want all three of them to reach the starting point together, what will I have to do? I'll have to take the LCM of 40, 24, and 15. I repeat, directions will not matter here.
Yes, ma'am.
Okay. And the last thing is number of distinct meeting points. So let's say if I consider only for A and B, where A is running at 30 and B is running at 50. What do I first mean by number of distinct meeting points? So if you observed, we saw that this was their first meeting point when they were running in the opposite direction. If you start from here, you might get a second meeting point over here. Then you might get a third meeting point somewhere here. So there are a lot of points at which they will meet, but after a certain point, that pattern will start getting repeated, which means that first point will again come in the picture, and then second, and then third, and that pattern will start getting repeated. So my question is, how many distinct points are there on the track at which they meet? Now, how do I find this is? This is a very good shortcut for this. If I'm talking about A and B, you just take the ratio of A and B's speed. The ratio of A and B speed is 30 is to 50. You try to reduce it as much as possible. So it is 3 is to 5. Now, if A and B are running in the opposite direction, the distinct meeting points would be 3 plus 5, that is 8. And if A and B are running in the same direction, the distinct meeting points would be 5 minus 3, which is 2.
So in the same direction, we take the ratio of the speeds.
But we take the ratio of the speed, reduce it as much as possible, but we take the difference between the two numbers. 5 minus 3. And in the opposite direction, we take the summation of two numbers, which is 5 plus 3.
Okay, got it.
Okay. Then with this understanding, shall we start with few questions? Okay.
Yes, ma'am.
Let's go. All right. Let's look at this question. Now, I want you guys to give me inputs. I will just follow your lead. Amol and Avash start moving simultaneously around the circular track from the same point in the same direction. This is important that their direction is same. Amol can complete one round in 16 seconds. So Amol can finish one round in 16 seconds and Avash can complete one round in 28 seconds. We don't have their speeds, but we have the time taken to finish one round. Okay. Find the time after which they would be together for the first time. Okay. How would you do this? How did we calculate the time taken for them to be together for the first time? What was the formula that we have learned?
Distance upon relative speed.
Correct. Length upon relative speed is what we'll have to do. Now we don't know the length over here. Okay, so I'm just going to put the length as L. Fine. What about the relative speed? Now we don't know their speeds also, but can we say, because Amol takes 16 seconds to complete one round, can I say the speed is L upon 16?
Yes.
And can I say Avash's speed is L upon 28?
Yes.
And because they are running in the same direction, the relative speed would be minus.
Minus.
So now if I try to simplify this, I think my L will be eliminated from both numerator and denominator. So what will be left is 28 into 16 in the numerator and 28 minus 16 in the denominator, which will give me 12. Can we try to calculate this? See which option matches.
112 by 3.
Correct. Clear?
Yes, ma'am.
Now the second point. Find the time after which they would be together for the second time. So if they are meeting for the first time after 112 upon 3 seconds, when should they meet for the second time? When should they meet for the second time? I told you one thing, that if anybody is meeting for the first time after, let's say, X seconds, when will they meet for the second time?
After X seconds.
Again, right? So basically, to meet for the second time, they will need twice the time.
Yes.
Okay, so that is nothing but 2 to 4 upon 3 seconds.
Yes, ma'am.
And when will they meet for the fifth time?
Into 5.
Into 5, which will give you
560 by 3.
560 by 3 is correct. I don't think any of these option matches, but yeah, there's an option on the second page which matches.
Yes, ma'am.
Okay. Moving ahead. A sprinter starts running on a circular path of radius r meters. So this circular path has a radius of r meters. So what can I say about the length of the path? Length is nothing but the circumference of the
Var.
circle, 2 pi r.
2 by R.
Correct? Circumference of the circle. Now her average speed is pi r. So her speed is pi r during the first 30 seconds, pi r by 2 during the next 1 minute, pi r by 4 during the next 2 minutes, and pi r by 8 during the next 4 minutes, and so on. What is the ratio of the time taken for the nth round to that for the previous round? So because they have asked me a ratio of nth to previous round, and n is left on to us, we can safely assume that taking any n will not change my answer. So let's say if I take n as 2, I need to find the ratio for the time taken for the second round upon the time taken for the first round. Do we understand this?
Yes, ma'am.
Okay, now let's look at this. How do we calculate? Now, the length is 2 pi r. So when I complete 2 pi r, that is when my first round will get completed. Okay. So now her speed is pi r during the first 30 seconds. So for first 30, now I'm talking about the first round, time taken for the first round. So for the first 30 seconds, yani half a minute, right? The sprinter is going to complete pi r. The speed of sprinter is pi r. I mean, in meters per minute is pi r, which means in the first 30 seconds, sprinter is running pi r meters in 1 minute. So in 30 seconds, sprinter must be running pi r by 2 meters. I'm writing the distance here to see that when my first round is getting completed. Do we understand this?
Yes, ma'am.
In first 30 seconds, half, where the distance covered is pi r by 2. Then in next 1 minute, my speed is pi r by 2, which means in this 1 minute, the round that I am covering, the distance that I am covering is again pi r by 2. Okay. In next 2 minutes, my speed is pi r by 4. So in these next 2 minutes, the distance that I am covering is pi r by 4 into 2. Do we understand this? Speed into time, which again gives you pi r by 2. And
Okay.
in next
Yes.
4 minutes, my speed is pi r by 8. So the distance covered is nothing but pi r by 8 into 4, which is pi r by 2. So you must be getting some hint up till now. What is happening? In every stretch of
Distance
time,
is pi r by 2.
correct. In every stretch of time, the distance is same, which is pi r by 2. So if I add all these four distances, I'm going to get 2 pi r. And that completes my first round. Do we understand this?
Yes.
So your first round takes nothing but 7.5 minutes. So now, without calculating the distance, can you tell me how much should your second round take? What should be the numbers that we would be adding?
Second round will take 15 minutes. 7.5 into 2.
No. So in this case, because the speed is not constant, it is changing every time. My speed in all the parts of the second round will also not be constant. So if this goes on, which means for the next 8 minutes, because I'm following the pattern, the speed is going to be pi r by 16. But we know
Why 8 minutes?
so they are talking about half a minute, 1 minute, 2 minute, and 4 minutes. So if you see this pattern, this is a pattern where they are multiples of 2, powers of 2. So the next pattern has
Yes.
to be for the next 8 minutes.
Okay.
But we know that for every stretch of these times, the distance covered is always same, which is pi r by 2. Correct?
Yes.
So first pi r by 2 will be covered in 8 minutes. Second pi r by 2 will be covered in 16 minutes. Third pi r by 2 in 32 minutes. And fourth pi r by 2 in 64 minutes. And that is how my second round will get completed. It's a pattern that you have to look at. Every time when you calculate the distance for these portions of time, you will still get pi r by 2 every time. Are we getting it?
Yes.
Okay, so if I total this up, 32 plus 8 is 40, 64 plus 16 is 80, 40 plus 80 is 120. So now I need to find the ratio of time taken for the second round to the time taken for the first round, which is 7.5. So I'm writing 75 and I'm adding a 0 over here. This ratio we need to find. So if I simplify this, 25 threes are 25 fours are 100, 25 eights are, and this is 16. So what is my ratio? 16 is to 1.
Got it, ma'am.
Understood, sure, both of you?
Yes, ma'am.
Okay. All right, moving ahead. In a 9,600-meter race around a circular stadium having a circumference of 800 meters. So the stadium has a length of 800 meters, right? But the race is 9,600 meters, which means how many rounds will the winner have to run?
9,600 divided by 800.
Which is
12.
12 rounds, right? The fastest runner and the slowest runner reach the same point at the end of 5th minute for the first time after the start of the race. All the runners have the same starting point and each runner maintains a uniform speed throughout the race. If the fastest runner runs at twice the speed of slowest runner, so fastest runner to slowest runner, the ratio of speed is 2 is to 1. Okay. Now, because both of them are running in the same direction, because it's a race, so of course, both of them have to be running in the same direction. Because this is the ratio of their speed, can you tell me the number of meeting points for the fastest runner and the slowest runner? What would be the number of meeting points? We did this, how to find the
If
number of
we
meeting.
are running in the same direction,
Yeah,
so for the same direction, it's the difference. So 1 meeting point.
Correct. The number of meeting points is going to be 1, which means the only point at which they will meet will just be the starting point, because starting point will always be one of the meeting points. Agreed?
Yes.
So the only point they will meet will be the starting point, which means after the end of 5th minute, the faster runner would have covered one round more than the slowest runner.
Yes.
So at the end of 5th minute, faster runner would have covered 2 rounds and slowest runner would have covered 1 round, and that is how they would have met. Only then their speed 2:1, I think, holds true, right? So 2 rounds is how much meters? 1600 meters. And 1 round is how much meters? 800 meters.
800.
Right? Now, what is my question? What is the time taken by the fastest runner to finish the race? Now, to cover 600 meters, fastest runner takes 5 minutes. So, to cover 9600 meters, fastest runner will take how many minutes?
30.
30, and that would be your answer. It's a cat question. If you see, there is more of logic and less of calculation in this. Generally, cat questions will have more of logic.
Yes, ma'am.
Okay, moving further. Now, these are the type of questions where I think that you should be able to do it by yourself. A, B, C, they start running simultaneously around the circular track from the same point in the same direction. So all three are in the same direction. Their speeds are given to us as 10, 15, and 18. If the circumference of the track is 900, find the time after which all of them will be together for the first time. So come on, one of you tell me how can we do it? How should we do this? We have done same question with different numbers in the explanation part. We want all three of them together. What happened? Hannah, how will we do it?
Ma'am, I am actually not able to see what you are representing, so I will just leave and rejoin once again because I've been having some
Are you
network
able to
issues.
see?
Yes, ma'am.
Okay.
I haven't been able to see a little bit, so I thought you weren't sharing. I'll just rejoin.
Okay. Gauri, how will we do it?
First, we'll convert their speed to meter per second.
Okay.
And so that will be into 18 by 5 or
5
5
by
by
8.
18.
To convert from kilometers per hour to meter per second, we multiply by 5 by 18. So if A and B have to meet, what will be the relative speed for A and B? 5 kilometers per hour into meter per second. Do we understand this? Whenever there are 3 people, what I wanted you to answer is we will make two people meet. That's what we did, no? In the explanation part.
Yes.
Then why
Ma'am,
so
can
dull?
you explain it once again? The 3 people point?
So whenever there are 3 people, I cannot make all 3 of them meet together in one equation. So what I'll do is I'll make, let's say, A and B meet. To for any 2 people to meet, the time taken is nothing but length upon relative speed. Because they are in the same direction, the relative speed will be 5. And to convert it into meter per second, I'll have to do 5 by 18. Did we understand this much?
Clear, ma'am.
Okay, so this is 36 into 18 seconds. I'm not solving this. I'm keeping it like this. Now I'm going to try to make any other two combination of people meet. Let's say B and C. So they are going to meet after what? 900 upon what will be their relative speed?
3 into 5 by 18.
Correct. 3 into 5 by 18. So this gets cancelled, and 900 into 6 is 5400. 5400 by 5 will give you 1080 seconds. Right? Now, if I want all of them to meet, A, B, we know that A, B will meet after every these many seconds. B, C will meet after every 1080 seconds. So to make A, B, and C meet together, I will just have to take
LCM.
LCM of 36 into 18 and 1080. 1080 also, if I can split, it is nothing but 36 into 30. Do you agree with this?
Why do we not take for A and C the meeting
We
point?
can take for any two combinations.
Okay, it's just for the two.
We just need to make sure that all the three members are there. Even if you take A, B, and AC, the answer will not be different. The only point why I didn't take AC over here was the relative speed would be 8, which would not have been very helpful with 900. But even if you take it, the answer will not change.
Got it.
Understood? If I have to take the LCM over here, the common factors from both of them is what? 36 into 6.
Yes.
And then the remaining factor 3 from here and 5 from here should be the time in seconds where they will meet for the first time. But what have they asked? All the times are in minutes. So what will I have to do? Divide by 60.
Uh, 54 minutes.
54 minutes should be your answer. Okay. All right. This is the same question, but the directions have changed. If you see, speeds of PQR are same as the previous question, but what is happening to the directions? P is running clockwise, Q is running anti-clockwise, and R is also running anti-clockwise. P speed is 10, Q speed is 15, and R speed is 18. Still the track is 900. Now, when will they be together for the first time? The question is same, but the relative speeds will differ. So for P and Q, what will be the relative speed?
Five. No, 25.
And because I'll have to convert, I'll have to do it this way. Okay. For Q and R, what will be the relative speed?
900 by 3 into 5 by 18.
Correct. And for P and R, what would be the relative speed?
28.
So you see, 28 is not a very friendly number. So I would not take PR. I would stick with PQ and QR as my combination. And the same thing, whatever I get, I'll have to take the LCM for them to meet for the first time. And this answer will
Yes.
give me the time in seconds. I'll have to divide by 60 to find the time in minutes. So will you be able to do this later by yourself?
Yes, ma'am.
Okay. Let's see this. A, B, C are moving on a circular track. A is the only one moving in the anti-clockwise direction. Which means B and C are moving in the clockwise direction. At a speed twice that of B and thrice that of C takes 10 seconds to cover the entire track. Now, if A takes 10 seconds to cover the entire track and A is twice faster than B, then B should take how many seconds to cover the entire track? A is taking 10 seconds for one round, and A is twice faster. A has the double speed of B. Then B should take how much time to cover the cover
5
5?
seconds. No, A is 10.
A
Fast.
So
is
be it
faster.
5
Beta,
or
A is faster. So if B is
20
slower,
seconds.
B should be taking more time. Speed
20.
and time are inversely proportional, not direct. Yeah.
yes, ma'am.
Again, A is thrice fast than C. So if A takes 10 seconds, C should take.
30.
Are we clear up till here? Now they all three start simultaneously. After how long will they meet for the second time at the starting point? Now, how do I find the time taken for three of them to meet for the first time at the starting point? How do we do that? I told you in the
The length
concept.
track
Reflect.
upon relative.
Sorry.
Length of track upon relative speed is the
That is for them to meet for the first time anywhere on the track.
yes.
But for them to meet at the starting point, the second type of question, how did we find that?
The LCM of the
LCM of
distances.
what is wrong with you guys? We just did it. We just did three types. How can you not remember those three types that we did what after before 15 minutes? First type we did was when they meet anywhere on the starting point. So that we did length upon relative speed. Second, we did where they have to meet at the starting point, not anywhere on the track, but at the starting point particularly. So for that, we took the LCM of time taken by them to complete one round each. Do we remember?
Yes, ma'am.
So what is the time taken by A, B, and C to complete one round each? It would be 10, 20, and 30. So what is
Yes.
LCM of 10, 20, and 30?
Ma'am, why are we taking the LCM of all three? In the last question, we just took LCM of two distance
That question
break.
was they can meet anywhere on the track. This question is they have to meet at the starting point.
Okay.
Second category. So to meet the starting point, all three needs to complete the complete circle. So to
Yes.
complete one complete circle, A takes 10 seconds, which means after every 10 seconds, A is going to be back at the starting point, right?
Yes.
Similarly, B is going to be back at the starting point after every 20 seconds, and C will be back at the starting point after every 30 seconds. So for all three of them to be there, you will have to take the LCM of 10, 20, 30.
Yes, ma'am.
Okay, so which means after 60 seconds, all three of them will be there at the starting point for the first time. So when will they be there at the starting point for the second time?
Into 2, 120 seconds.
Correct, because they will be at the starting point after every 60 seconds together. Are we getting it? Why LCM? You see, A
Yes,
is there
ma'am.
at every multiple of 10. So 10, 20, 30, 40, 50, 60. B is there at every multiple of 20. So 20, 40, 60. C is every multiple of 30. So 30, 60. Which means all three will be there at 60 seconds. And again, so every 60 seconds, so 60, 120, 180, 240, it goes on.
Yes, ma'am.
Okay. Next. Let's look at this. Chiku and Charu, they are running along a circular path with a diameter of 1050. So first let us understand and find the length of the path. If the diameter is 1050, which means the radius, which means 2r is 1050, How do I find the circumference of a track or length of a track?
2 pi r.
2 pi r. So it is nothing but 2r into pi. The value of pi is what? 22 by 7. If I calculate this, so length of the track is 3300 meters. Did we understand this first step first?
Yes, ma'am.
Yeah.
Yes.
Now Chiku's speed is 15. Charu's speed is 25. Their direction is not given to me as of now. And Chaman is running along the path AB, which is diameter, which means this. So Chaman is not running on the circular path. He is running linearly on the diameter at a speed of 35. Chaman turns back immediately after reaching the point B and does the same as he reaches the point A. So for Chaman, if he starts from A, goes to B, comes back to A, goes to B, comes back to A, goes to B, this is how he runs. Okay. Now all of them are starting from point A together. Okay. Now let us read the question. If Charu and Chiku, they are running in the opposite direction. So let's say this is point A and this is point B, and they are all starting at point A. Okay. Now if Charu and Chiku, they are running in opposite direction like this, right? With Charu's speed as 15 and Chiku's speed as 25. What is the shortest distance along the circular path between point A and the point at which they will meet for the third time? So first of all, I need you to find when will they meet for the first time? What is the length of the path?
3300
So how
meters.
do I find the time taken for any two people to meet for the first time anywhere on the track?
The length of the track upon relative speed of both.
Good. So length of the track is 3300. What will be the relative speed?
It's opposite direction, so the difference between their speeds.
Oh no.
10 meter per second. No, sorry, the sum. So 40 meter per second.
So 330 by 4 will be the time taken for them to meet for the first time. Agree?
Yes.
So now when will they meet for the third time? What will be the
Into
time
3.
taken? That would be into 3, which is nothing but 990 by 4. Are we together up till here?
Yes, ma'am.
Okay. Now we need to find the shortest distance between point A and the point at which Charu and Chiku will meet. So clearly at 990 by 4 seconds, both Charu and Chiku have to be at some common point. So let us try to find that common point by picking up any one of them. Let's say Charu. So I need to find that at a speed of 15 meter per second, Charu would have covered how much distance in these many seconds. So how do I do that? 15 into distance is what? Speed into time.
Yes.
So let me try to now. I'll have to kind of start reducing it. I will not be able to work further without reducing it. So this is what? 495. Okay, if I reduce it further, 247.5. So what is 15 into 247.5? 15 fives are 75. Always start the calculation from behind. 15 sevens are would be 105 plus 7, 112. I really hope that you are aware of the tables. 15 fours are 60 and 11 gives me 71 and 15 twos are 30 and 7 gives me 37. Are we with me over here? I mean, till this point?
Yes, ma'am.
Okay, so now let us track Chiku's motion. Chiku would have covered 3712.5, which means Chiku would have finished one round of 3300. And after that, Chiku would have covered 412.5 meters more. Right? So what is the shortest distance between this point and point A? Are we getting this?
Ma'am, so uh, the shortest distance between A and that point?
Correct.
So would that be 412.5 itself? Because one.
Yeah, it is.
Yes, ma'am. Clear, ma'am.
All right.
Yes.
Similarly, let's try to look at the eighth question. If Charu and Chiku are still running in the opposite direction, what is the shortest distance between Charu and Chiku when Chaman reaches point B for the fifth time? So what we'll have to first find over here is how much time does Chaman take to reach point B for the fifth time? Now we know Chaman's movement. So Chaman reaches point B for the first time. So 1050 meters he has to cover at a speed of 35 meter per second. So can you tell me how much time will he take?
30
30
seconds.
seconds, right? So Chaman will be taking 30 seconds to reach point B for the first time. And again 30 seconds to go back to point A, 30 seconds to go back to point B. Do you understand what I'm trying to say?
Yes.
So basically, to reach point B for the first time, how many times will he have to cover the diameter? 1, 2, 3, 4, 5, 6, 7, 8, 9. Understood? So he is in total going to take 270 seconds to reach point B for the fifth time. If there's any doubt, please ask at this point.
Ma'am, I did not understand how the 30 came.
Okay. So the distance is 1050 and
Yes, ma'am.
speed is 35. The time taken is distance upon speed
Ah,
1050 upon
got it, ma'am.
35. So to cover one stretch of diameter, 30 seconds.
Got it, ma'am.
Okay. Now, basically, I need to now know the position of Charu and Chiku after 270 seconds, correct? So let's
Yes.
try to do that. Chiku has a speed of 15. So at a speed of 15 and time 270 seconds, how much distance should Chiku cover? Calculate and tell me.
Their speed is still 45 meters per second.
The speed is 15 and 25 respectively
Okay, we are calculating for Chico.
for Chiku.
The distance he covers is 4050 meters.
I guess I'm trusting your calculation.
Yes, ma'am.
Okay, and for Charu, what will be the distance covered?
6750 meters.
Okay. So now, which means at this 270 seconds, let us try to locate the position of Chiku and Charu on the track. Okay. If Chiku is moving in this direction, 3300 ka to track hai. So after completing 3300, I think more 750 is left. So Chiku must be
Yes.
somewhere here. Similarly for Charu, Charu is going in the anti-clockwise direction, and with 3300 and 6600, more 150 is left. I hope everybody is getting what I'm trying to do.
Can you explain it once again? After finding the distances?
So after finding the distances, try to track the movement of Chiku. Chiku completes a round of 3300, but to finish 4050, still 750 more has to be done.
Yes, ma'am.
Similarly, for Charu, Charu completes 3300, 6600, and more 150 is left.
Yes, ma'am.
So that is
Yeah.
where their positions are. Now, what is asked to me? What is the shortest distance between Charu and Chiku along the path? Which means I need to find the shortest distance between Charu and Chiku. There are two distances between Charu and Chiku, the above one and the below one. If you see, the above distance is 150 plus 750, which is 900. Agreed?
Yes, ma'am.
And the below distance
Yes.
has to be 3300 minus 900, which is
Got
So
20.
it.
the shortest will be 900.
Correct. Here it is. Did we understand?
Yes, ma'am.
Moving further, let's look at this. Three people, A, B, C, they start running clockwise. So all three are in the same direction. Who's on a circular track whose radius is this? So can I first find the length of the track? Length of the track is what? 2 pi r, where the value of radius is given to me as 105 upon 2 pi. So what is the length of the track? Correct? Now the ratio of the speeds are given to us as 3, 5 and 7 respectively. What is the difference between the distance traveled by A and the distance traveled by C when all three meet for the first time at a point on the track? So I need all three of them to meet together. Okay, so let me first assume the speed of A to be 3, speed of B to be 5, and speed of C to be 7, because that is the ratio given to me, and all three are in the same direction. Fine. So when if I want all three of them to meet for the first time, what do I do? How do I find the time taken?
Ma'am, to make them meet for the first time, do we take 3, 5, and 7 in the same direction? So, like, do we take it in pairs like we used to?
We will have to, yeah.
So, B and C would be 105 by 2, the total
Okay.
distance divided by the speed.
Okay.
And then A and B can be 105 by 2 again, which is similar.
Correct.
And then A and C can be
But we need
4
only need two of them. So you can let
only
go of
2.
A and
Okay,
C.
ma'am.
If I have to take the LCM of 105 by 2 and 105 by 2, it will be 105 by 2. Agree?
Yes.
Right? So this is the LCM in terms of hours. Now, difference between the distance traveled. So at the speed of 3 kilometers per hour and for this much time, the distance traveled by A would be what? 3 into 105 by 2.
Yes, ma'am.
And distance traveled by C would be what? 7 into 105 by 2.
Yes, ma'am. And B would be 5 into 105 by 2.
But we just need the difference between A and C.
A and C.
So the difference between the distance is nothing but 4 into 105 by 2. Correct?
Yes, ma'am.
Which is 210. All right. Moving further. Okay. This is like a mentally to be done mentally question. A and B, they start running simultaneously on a track of 720 meters in the same direction. The speeds are given as 35 and 10. At how many distinct points will they meet? How do you find the number of distinct points?
Distinct points is the ratio of their speeds and then the difference.
So 35:10. I reduce it further.
7:2.
So what will be the number of distinct points?
5.
5 is the answer because they are in the same direction. And same question if they are in the opposite direction, the number of distinct points.
Opposite directions we add. So 7 plus 9, yes.
7:2 and you add, so it becomes 9. Let's look at this. Maitri, Sanaya, and Shia, they start running simultaneously on a circular track of 1500 meters with speeds of, so where Sanaya and Shia, they are running in the same direction, whereas Maitri is running in the opposite direction. So let's say Shanaya, Shia, and Maitri. Maitri speed is 80, Shanaya speed is 40, and Shia speed is 10, and the track is 1500. Find the number of the meeting points where all three meet. So first of all, let's try to see the number of meeting points where Shia and Shanaya meet. The number of meeting points for Shia and Shanaya. How many meeting points would there be
7?
for Shia and Shanaya? 3, no?
Yes, ma'am. Sorry, 3.
Okay, so basically one meeting point has to be the starting point, and because it is 3, the circle has to be divided into 3 proper courses. So these has to be the 3 distinct meeting points for Shia and Shanaya. Okay, if I talk about, let's say, Maitri and Shia, what can be the number of meeting points? For Maitri and Shia, their directions are opposite, so the number of meeting points has to be 9, right?
Yes,
Isn't the
ma'am.
ratio 4:1?
It that was for Shia and Shanaya, 4:1, but same direction, so 4 minus 1, no?
Yes.
For
Okay.
Maitri and Shia, it is 8:1, opposite
8:1.
direction, so 9.
Yes.
So I have to divide circle into 9 equal parts. So if Shia, Shanaya, they meet at the blue points, and Maitri, Shanaya, they meet at the red points, which means these 3 are the points where all 3 meet. Do we understand this?
Yes, ma'am.
Let's look at this. Meera and Amal, they walk along a circular track, starting from the same point at the same time. If they walk in the same direction, then in 45 minutes, Amal completes 3 more rounds than Meera. Okay. So I have not been given any information on their speeds and length. Let us say the length is L, the speed of Meera is SM, and the speed of Amal is SA. Okay. Now, if they are walking in the same direction, so the relative speed has to be minus, and Amal completes 3 more rounds, which means Amal is, of course, faster, right? So when I say Amal is completing 3 more rounds than Meera, the relative distance between them has to be the distance of 3 rounds. Do we understand this?
Okay.
The relative speed between them has to be SA minus SM, and the time taken for them to do this is 45 minutes. If they walk in opposite direction, then they meet for the first time exactly in 3 minutes. So if they are walking in the opposite direction, they are covering only one round, right? Where their speed is SA plus SM, and they are taking 3 minutes to do this. So if I
Yes.
try to now kind of, equate or relate these equations, what will I get? So if I multiply both the equations with 3, this becomes 3L and this becomes 9. So I can say 45 into SA minus SM is equal to 9 into SA plus SM. 9 fives are, so 5A minus 5 SA minus SA is 4 SA, and SM plus 5 SM is 6 SM. Is everybody with me?
Yes, ma'am.
So this is the ratio of speeds of Amal and Meera. Okay. Now what is asked? The number of rounds that Meera walks in 1 hour. So when I got the ratio of speeds, if I put it in any of these equations, can I get the length of the round? Okay. If I put in any one of the equations, let's say 3L upon 3 minus 2 is equal to 45. So I can say L is 15. Right? So if length is 15 and the speed of Meera is 2 meters per minute. Length is 15 meters, and because everything is in terms of minutes, I'm taking the time in minutes only. Speed of Meera is 2 meters per minute. So in 1 hour, which means 60 minutes, Meera will cover 2 meters into 60, which is 120 meters. And if one round is of 15 meters, when Meera covers 120 meters, she actually covers 8 rounds. Do we understand this?
Yes, ma'am.
Okay. Moving ahead. It takes pendulum of a clock 9 seconds to strike 6 o'clock. So what do I mean by pendulums striking at 6 o'clock? Have you ever come across a clock with a pendulum? What does it do to strike 6 o'clock? Any idea?
9 back and forth swings.
9 back and forth swings?
Sorry, 9 swings. One forward, one backward.
But why 9? I'm supposed to strike 6. So basically, to strike 6 o'clock, what does a pendulum do is tung, 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 tung. It strikes 6 times. So pendulum clock is basically when at every complete hour, it strikes the number of hours. You don't have to look at the watch. If you count the strikes, you will understand the time. Do we understand this?
Yes, ma'am.
For doing this, pendulum takes 9 seconds, which means if you see there are 1, 2, 3, 4, 5. So there are 5 gaps, and 5 gaps take 9 seconds, which means one gap will take 9 by 5 seconds. Now, similarly, to strike 12 o'clock, if I have to strike 12 times, what will be the number of gaps? 11 gaps. If I'm striking 12 times, the number of gaps have to be 11.
Yes.
So if one gap takes 9 by 5 seconds, 11 gaps will take 11 into 9 by 5 seconds, which is 99 by 5 seconds. And that would give you 19.8 seconds as the answer. Okay. All right. Moving further. Now we are starting with the questions related to clocks. So for that, first let me explain some concept and then let us go ahead with the questions. Okay. So for clocks, why is it first of all combined with the circular races? Because we see the hands of a clocks like running on a circular race, and we're talking about two major hands, the minute hand and the hour hand. Okay, and here you don't have to worry about the, I mean, direction, because minute and an hour hand has to go in the same direction. It's a clock, and we're talking about analog clocks, not digital clocks. Fine. If I talk about a minute hand, can I say minute hand covers entire 360 degrees in 60 minutes?
Yes.
Which means in 1 minute, minute hand should be covering 6 degrees. So this is the speed of minute hand. Do we understand this?
Correct.
Similarly for hour hand. Now you know that for a clock is nothing but divided into 12 parts. And because the entire clock is 360 degrees, every part is 30 degrees. So for an hour hand, can I say that hour hand covers 30 degrees in 1 hour, which is 60 minutes? In 1 hour, hour hand will shift from 1 to 2, only that much. So covering 30 degrees in 60 minutes, which means the speed of hour hand is nothing but half a degree per minute. So if I have to talk about minute hand and hour hand, the relative speed, because they are always in the same direction, will always be 5.5 degrees per minute, which means if the minute hand is up, whenever the clock starts at 12, minute hand being faster will always move further. So minute hand is always going to cover 5.5 degrees more every minute than the hour hand. Okay, all right. Now this is one basic understanding of the movement of minute hand and hour hand. Now generally, what type of questions do we get in clocks? So one question is, um, angle between the hands at a particular time. So let's say in a clock, I am told that right now my clock is at, the time in the clock is, let's say, 6:10. What is the angle between the minute hand and the hour hand? So how would 6:10 look like? Somewhere like this. Of course, the hour hand will not exactly be at 6. Do you understand this? Okay. So what will be the angle between the hands at 6:10? Now, how do I find this is? What do I do in such questions is, I always start with the complete hour. Let's say I start with 6 o'clock. Now, after 6 o'clock, I need to go 10 minutes more. So in 10 minutes more, minute hand would have covered how much angle?
3 degrees.
60 degrees, because minute hand would be at 2. So minute hand would have covered 60 degrees, right? And in these 10 minutes, hour hand would have covered how much angle? 5 degrees,
Yeah.
right? And between 2 and 6, the angle is already 120 degrees. So can I say the angle between the hands would be 125? Did we understand what we did? Angle between the hands?
Can you
Yes, ma'am.
explain the hour hand once? I got the minute hand.
Okay. So our hand, we know that it moves at half a degree every minute. So in 10 minutes after 6, it has to move 5 degrees more, no? It will not be exactly at 6, it will be slightly forward.
Got it, ma'am.
So half into 10, 5 degrees more. So that is why This blue mark is where the hands will exactly be at.
Yes, ma'am.
Then next is time at a particular angle, which means if I'm asked, when will the angle between the hands be 60 degrees between 3 p.m., 3 to 4. See, one more thing I want to tell you is between every 1 hour, every angle comes twice. So, for example, between 3 to 4, so this is 3 o'clock, right? So, one time angle will be 60, somewhere around here, and another time angle will be 60 somewhere around here when the minute hand crosses the hour hand. Do you understand what I'm trying to say? In every
Yes,
1 hour, so let's say between 3 to 4, 60 degrees between the angle will be at two different points. One point is where the hour hand will be above the minute hand, and another point is where the hour hand will be below the minute hand. Fine, and this goes for every angle, except, let's say if I have to say that when will the angle between the hands be 90 degrees between 3 and 4? Now 3 itself is 90. So between 3 and 4, 90 will come only once. Similarly, 4 itself is 120. So between 3 and 4, 120 will come only once. One more time except this 4. One more time 90 except the exact 3. But except 90 and 120, all the other angles will come twice. Are you getting my point?
Got it, ma'am.
So if I have to calculate this, that at what time between 3 and 4, the angle between the hands will be 60, how do I do it is, what do I do is, I first start with my base value of 3 o'clock. So 3 looks exactly like this, where the angle is already 90. Now, if I want my angle to be 60, I want that my minute hand should relatively move for 30 degrees more. First, are we clear with this case? We want this angle to be 60. So if the angle has to be 60, the minute hand has to relatively move 30 degrees more, right? Of course, अगर minute hand चलेगा तो hour hand भी चलेगा. So I cannot take this speed of minute hand or this speed of hour hand. I have to take the speed which considers both their movements, which is the relative speed. So to cover 5.5 degrees relatively, where movement of both hour hand and minute hand is captured simultaneously, it takes 1 minute. So to cover 30 degrees, it should take how many minutes? Should be your answer. So 30 into 1 divided by 5.5 should give you 300 by 55, which is 60 by 11. So 3:05 and 5:11 seconds at 3:05, 5 by 11, the angle between the hands will exactly be 60 degrees. If you're not understanding these, please ask. Again, it's an important type of a question.
Ma'am, can you explain the last part once again? The part where we consider the 60 degrees and then the 30 degrees extra that we take for the 90 degrees.
So
after that,
already at 3 o'clock, the angle is already 90.
yes,
Okay.
ma'am.
You want the angle to be 60, which means the minute hand will have to move 30 more so that the angle between two hands is 60.
Got it, ma'am. So we use the relative speed to consider the rest 30. Got it.
Because even hour is moving, no?
Yes, ma'am.
So I can't just take minute hand. That is why I'm taking a speed which considers both the movements.
Got it, ma'am.
Okay. Now, this is one case where the angle between the hands will be 60. What will be the other case where the angle between the hands is 60? When the minute hand crosses the hour hand and is somewhere here. So to cover this much part, minute hand has to cover how many degrees relatively? This 90 plus this 60, so 150 degrees. Do we understand this?
Yes, ma'am.
So now same relation, to cover 5.5 degrees, I take 1 minute. So to cover 150 degrees, I'll take how many minutes? That will give me 1500 upon 55, which is 300 upon 11, and that will give me 25 5 by 11. So your next answer will be 25 5 by 11. So at this two different timings, the angle between the hand will be 60 degrees between 3 and 4 o'clock. These are the two major type of questions, except the errored clocks questions, which we will keep on seeing when the questions come. So for example, the one on this page itself is an errored clock question. So let us look at that. Okay. A clock is gaining 12 minutes every 24 hours. What is this? What is the meaning of this? This is not a correct clock. Every 24 hours, the clock is showing 12 minutes extra, which means if today the clock is correct at 2 o'clock, tomorrow 2 o'clock, it will show 2:12. Then in next 24 hours, so day after tomorrow at 2:12, it will show 2:24. So if clock is gaining 12 minutes every 24 hours, so can I say that the clock is gaining half a minute every 1 hour? Okay, clock is gaining half a minute every 1 hour. Now, what is told to me that at 6:15 p.m. on Monday, the clock is set right, which means it is showing 6:15 at 6:15, no error. What will be the actual time when the clock shows 1:35 p.m. the following day? Okay. So clearly in the previous day, the correct time is 6:15 and what it is showing is 6:15. But the next day, what it is showing is 1:35 and what you need to find is the correct time. Okay. So first of all, 6:15 to 1:35 is how many minutes? If I have to go by the minutes, that would be easier for me in this case. First of all, hours and then minutes. So 6:15 to 6:15 a.m. is what? 12 hours. And then if I go ahead, 7, 8, 9, 10, 11, 12, 1, 7 more hours. So 19 hours and 20 minutes. Did we understand the gap?
Yes, ma'am.
Between the two times shown. Okay. Now, just for the ease of my calculation, if I want to convert everything into minutes, that would also be helpful, right? If you see over here, I am gaining half a minute in every 60 minutes. Basically, every 60 minutes is showing me 60.5 minutes. If I want to skip this much time, how many minutes should have passed? So 19 hours is what? If I have to convert it into minutes, 19 into 6 will give me 95, 105, 115, and 114. 1140 plus 20 is 1160. So for the clock to show 60.5 minutes, clock has to go 60 minutes originally. This is the correct one, this is the wrong one. So for the clock to go wrong time of 1160, I mean to travel 1160, how much correct time will the clock have to travel? Did you understand this?
Ma'am, can you explain that once again?
So we know that clock is gaining half a minute in every 60 minutes, correct?
Yes, ma'am.
Which means when the clock correctly travels 60, it incorrectly travels 60.5.
Yes, ma'am.
Now for the clock to travel 1160 incorrectly, how much correct travel is required is what is told.
Got it, ma'am.
Okay, so now if I try to calculate this, 1160 into 60 upon 60.5, I should get my approximate answer in minute. This calculation will be little tedious, but at this point, I can convert this entire thing into seconds. But again, I don't think that is going to really help. Okay, so if I have to start at least 5 12s are 60, 5 121s are, and 5 2s are 10, 5 3s are 15, 5 2s are 10. Okay. Um, Nothing else is actually getting cancelled. If I see this clearly, 232 by 121 is slightly less than 2, and 600 into 1 upon 121 is slightly less than 5. My answer should be slightly less than 10, basically, right? So if it has to cover, let's do one thing. Let us try to convert this into hours, because our calculation in this case will be reduced if I convert it into hours instead of minutes. So if I convert it into hours, this entire equation will be divided by 60. So this becomes 10. This is what? 5 2s are, and this is 5 121s are. So let me do the numerator part. 2 zeros are 0, 2 6 are 12, 2 ones are 2 and 3, and 2 ones are 2 upon 121. So clearly, how many hours does the clock have to cover after 6:15 p.m. on previous day? We can find from here, right? 10 hours तो हो ही गया. 121 into 1 is 121. What am I left with? 111. So I write it over here. It is closer to, quite complex the calculation is going. But in the errored clock situation, mostly this will, what will happen? 1110. So it is, of course, you already know that the clock has surpassed 19 hours. No? So what is 121 into 19? I don't think this is a. So if you see, the clock has to already surpass 19 hours and few more minutes, right? So if I see from 6:15, if I have to surpass 19 hours, I already have to cross 115, and then it is crossing 20 minutes, and in this case 2299. So how many more minutes will the clock have to surpass? 299. So 21 minutes more. Can't be 21, it has to be lesser. Wait. We know that at 6:15, the time is 6:15. So if every 60 minutes of correct calculation, the clock is showing 60.5. So at every, we calculated 19 hours and 20 minutes. The clock should show how much? 19 6 is 114, right? This is 1160 minutes. There was some error in that because the answer cannot be more, it has to be less. If I convert this into hours, this is the hours that the clock will have to surpass. So 2320 upon 121. Can one of you do on the calculator what we are getting in this? 2320 upon 121. Where are we faulting here?
Ma'am, it comes around 19.17.
19.17.
Yeah,
Hours.
173 and it continues.
Okay. Which means after 6:15, if I have to go for 19 hours, I've already reached 115 next day. Now 0.17 hours takes me where? So 1 hour is 60 because I'll have to go minute wise. So 16 to 0.17. So how many more minutes have I surpassed is what I'll have to calculate. So 6 sevens are 42, 6 ones are 6, 7, 8, 9, 10. So approximately 10 minutes more I have passed. So 115 and 10 minutes more is 125 and then few seconds. This should be your ideal answer. What did we do? We did not, the one that we followed earlier, the method was correct. We converted the entire calculation to hours, so my numbers become smaller. So basically to cover this much time incorrectly, I will have to cover this much time correctly. So when I'm covering 19 hours straight, I'm reaching 115 for sure. But for more 0.17 hours, how many minutes do I have to cover is what I calculated. And this should be the correct time when the clock was showing this. Do we understand now?
Yes, ma'am.
Okay. All right. What does this question say? In a watch, the minute hand crosses the hour hand for the fourth time exactly after 4 hours, 16 minutes, and 15 seconds of watch time. What is the time gained or lost by this watch in one day? So generally, if I have to talk about a regular clock minute hand will cross the hour hand at after every 65 5 by 11 minutes. At every 65 5 by 11 minutes, the minute hand will cross the hour hand. Right? Which means if the minute hand has to cross the hour hand 4 times, it has to be 4 into 65 5 by 11. Correct?
Yes, ma'am.
And this one is the correct one. Right? So if I have to convert this, let's say, into hour format, or इस minutes को भी अगर मैं थोड़ा सा simplify कर दूं, what is 65 into 11 coming down to? 11 5s are 55, 11 6s are 66. 66 plus 5 will give you 71. What is the time gained or lost by the watch in one day? Clearly, the time will be, so when I say they are meeting for the fourth time in this much time, which means when they meet for the first time, it would be after 1 hour, 4 minutes, and somewhere around 4 seconds. Right? So 1 hour is 60 minutes plus 4 minutes plus 4 by 60 seconds. So 64 115. So they are meeting after every 64 115 second, which is the wrong clock, and they should meet after every 65 511 minutes. Sorry, I've calculated everything in minutes, which is the right clock. So now definitely there's a time difference. Instead of meeting at this, they are meeting at 64 1 by 15, which means it is becoming faster, which means they are gaining time. They are not losing time, they are gaining time because the clock is becoming faster. They are meeting at a faster pace, right? So the difference between them is what the clock will be gaining every hour. And when I multiply that by 24, I'll get the time gained, which is in one day. Fine. So if I want, we can calculate 11 fives are 55 and 6, 61. So 615 plus 5 by 11, sorry, 715 and 5 by 11, which is 720 by 11 in the first case. And in this case, it will be 15 fours are 60, 15 six are 90, and 6 960 plus 1 961 by 15. So the difference is what the clock is gaining in one day. And when you multiply that difference with 24, you will get it an entire day. And this is already in minutes, so the answer should be directly obtained. Okay, try this. Next time, if you're not getting the answer to this, let me know.
Yes, ma'am.
All right.
Thank you, ma'am.
Thank you.